Did you know that LinkedIn was breached in 2012 and passwords were of 6.5 million users were leaked and could be cracked by hackers? This is cryptography or a part of it, and when cracking passwords, we're using cryptography knowledge to understand how the passwords are created. But we also need to know cryptography to know how to create strong passwords. And secure our systems, because a lot of them are secured by strong passwords and strong password algorithms that can ensure that we are not being listened upon when we communicate on the internet, for example, when using the internet protocols. And there you can use the HTTPS. So part of this is we use, for example, when I talk about the internet, we use the CRC32 to checksum for sending data. So it checks if this has been manipulated, the checksum for sending the data in the data protocol. And we use the hash values. So these are important if you want to dig in deeper to cryptography, because they can help us to see if unencrypted and they can be used on unencrypted and encrypted data. And the MD5 for hashing digital signatures. So it's important to have checksum in data transmission, and that's because then we can ensure that these are safe communications, that people are having an unlistened or non-eavesdropped communication between them on the internet. And this can have some bandwidth problems in transmitting information in space, and and different approaches to making the checksum there are to be found. And but mainly of all, what you need to know is that the data layer model is important to know of in this situation, because this is where you need to implement you need to aware of that there are these checksum in the layer model here. So where we have the IP address at the bottom, at the top. Don't hang up on that, but you have the physical layer, you have the data layer, you have the all the other layers for when you're communicating in the data layer, and this is specifically in the data layer. So what is important here is the password security, also a part of the cryptography, and that's where we really can see the implementation of it, and that's where you perhaps get the best understanding if you are new to the topic. And as I've said before, LinkedIn was breached in 2012. 6.5 million users were breached, and LinkedIn tried to mitigate the risk, and they encouraged their users to, first of all, they reset all the users' passwords, and then they make the users quickly try to make a new password so they could get their account back, or ensure that they still had access to their account, because this could, it showed that this encryption LinkedIn had was so weak as SHA-1 encryption. That's very weak. So they needed to also enforce that the users were trying to make better passwords for the next password. In this in this situation, they also wanted to implement better structures for having security, so they implemented multi-factor authentication and made a more robust security system. If you want to know if your password has been leaked, then you could go to pwned.org, and see if your password has been leaked in any breach. You can also go to the key store generation to get a secure password, and then the human factor is important in this part of the password, because that's where we go beyond from where we are just ourselves, but this can be crucial for identification on the internet. That we create strong passwords so we ensure that nobody else get in than us. So specifically when hackers go in and try to breach these passwords or accesses, they will try to they have some rainbow tables, and they have they use that for different kind of hash values, as I talked before, and these are values that are passwords, that typical passwords have a specific hash value, and if they somehow, the hackers, they know that within the English language we have these certain hash values for people over 60, then they can go and with that logic go and see, okay, and they store a hash, the rainbow table they buy on the dark web, that can give them a forehand in trying to brute force these passwords. So these rainbow tables, they have, because passwords are hashed, so they go in and then they will try, they just need the hash value, and then they iterate through these until they find the correct one. And if you have the more characters you have and complicated your password is, of course, then it's harder for them to, they will have to use more compute power, and they have to use longer time to crack the passwords. So what are so how do we prevent such attacks? Well, a part of this is assault, and this is a way that we avoid. We only store the hash value. So you get the hash value, and then you have the cell value that can, and you get a cell value to you sent, and then this cell value, if we have it here, will you have a password. That cell value will try to somehow encrypt your password. The cell value that's known from Google, for example. So Google has sent you that cell value to encrypt your password. They will and then the cell value will be known by Google, and your password will be stored as a hash value. So that the hackers don't know the cell value, and the cell is what is added to get the actual and it's only known by you and the Google. So these two. So if there comes some third party to try to brute force your password, they will only be in the database. They will only see this hash value. That will be very hard to crack. Almost, yeah. So that adds a very good protection for your password. So what we will also need to know about when we talk about cryptographics is when people are using confusion, obfuscation, and attacks in order to get hold of passwords. So they will try to put some kind of internal glue for spying on you. So they will try to get some. They will try to put something together, and then they will try to. I'm not sure about that, but let's just stay on track here. So combining the obfuscation attacks. So here they will try to get like that's they will take a DDoS attack. They will take some kind of other attack, and then they will try to obfuscate you, so you won't, or different places, so you will not think more of this. So when they get in there, or somehow they place some kind of program in all of this obfuscation, and somebody presses something that will eventually reveal the passwords or get them access to the passwords. I don't know actually of the example of the US, but that's an example that's US was a USA attack on CPU inside hardware drive. So this can be done in many different levels of these attacks, because that's particularly things can be really good encrypted using the CPU in the hard drive. And the obfuscation is a payload for delivery method. So they will try to create this fuss that, somebody, oh, look at me over here, and like we trying to make a DDoS at somewhere. Our servers, our front page is down, but actually in some way they maybe get in somewhere else in the middle of this obfuscation, because they put stress to the system, and the system, when they are under stress, they will eventually they will have more weak links spots to get in, and then they get in. So one of these ways of ensuring that passwords can help you to ensure zero trust, and use SSL and PKI, so primary key, and SSL for securing these communication lines, so you ensure that you can keep up with the zero trust policies. So, and that involves updating certificates and ordering SSL, TLS certificates, so you can always renew them and get them, and from your central authority. And you will always have to ensure that passwords can help you ensure that you can trust the other authority at the end, depending on the encryption level. And so therefore SSL and PKI are good solutions for implementing a secure way in terms of cryptographics, and we can validate by using, because these SSL and PKIs, when you communicate on the internet, they are being stored inside the big companies, so they will help the websites when you communicate around the internet. They will help them authenticate those. So when you search on Google, for example, you will always know that you are communicating with a trusted website, because they will store these SSL PKI values inside their inside the database. So this is and this can have a good importance, because you can also use them more locally, or you can always look for these in order to secure that you communicate on trusted lines, so you don't go out there and trust somebody who's not SSL. And you can set the standard to that. So not going on HTTP, but going on HTTPS always when you search on the internet from a company computer. What is really important to remember, that this is a part of the CIA triad, the triangle here. So we need to ensure confidentiality, that we can do by encrypting. We can ensure the integrity by hashing our values in the database, and we also have to be aware of availability. So we always so somehow if we put in good measures or ways of implementing these into focuses and structures, ways of implementing these intimate cryptography into the organization, that could have a very positive impact. And we can use the primary keys for authentication. So that's good. What is known in here? We have the evil twin attacks and security threats. So we always need to know about the evil twin attacks, and we need to be that they can be possible attack vectors and surface areas, and we always have the Diffie-Hellman algorithm to ensure this, and time attacks and username password rejection. So here are some examples of things we need to be aware of when we ensure our organization, and we need to and we always need to only reveal information to those who need to know it. So that's also part of our zero trust implementation, that we don't show things. If people don't need it, they don't need to see it when they work. So and that's helping us protect and keeping the secure environment. So thank you very much for watching.